Welcome once again. I'm Charlie Greenberg, your host and moderator for Digital Business Demos. Thanks for joining us today as we continue to provide live business demos that focus on different digital transformation and platform strategies, and in particular, demonstrate different components and products within Software AG's digital business platform. And when it comes to a common, scalable platform to store, cache, and compute trillions of gigabytes of in-memory data, Software AG strongly recommends Terracotta DB, and in just a moment, we'll be hearing from Vice President of Product Management, Manish Devgan, and Senior Product Manager and today's live demoer, Shaleen Prasad. Of course, today's presentation and live demo, in addition to Shaleen's expertise, is brought to you by Software AG, a customer-centric leader in many innovative and digital technology categories. Additionally, we have more than 4,300 employees, $1 billion in annual revenue, and we can cite over 70% of the Global 1,000 as customers. And those customers include over 2 million developers at leading organizations who have adopted Software AG products to innovate solutions and build applications cross-industry, cross-private and public sectors, and who rely on Software AG to help complete their journeys as digital enterprises through the end-to-end capabilities of the digital business platform. Always, as usual, please keep in mind that following today's presentation, we will provide a Q&A session. So use the Q&A WebEx box at the bottom right-hand side of your screen at any point in time during the presentation for any questions and comments. And with that, it's my pleasure to introduce Manish Devgan.
Thank you, Charlie. Happy to be here. So yes, today we are going to be covering Terracotta in-memory data platform and its capabilities, and also include a demo elaborating how to leverage webMethods integration adapter to facilitate data ingestion and building services using data from Terracotta DB. So let me start by giving a quick overview and introduction of the data platform. The Terracotta is an in-memory data management solution, and as Charlie indicated, there are several hundreds of customers we have on this platform. Several petabyte of deployment. We also have open source projects, so it's a very widely used platform across the Java ecosystem. If you look at the digital business platforms on Software AG, we fall into the real-time data and analytics set of capabilities, but also Terracotta powers some of the other core capabilities from the Software AG digital business platform, some of them being integration server and also our process and application platform in the DBP. So not only is Terracotta offered as a real-time data platform and analytical platform, but also powers various other core capabilities of the DBP. If you look at the Terracotta technologies and the data platform, this is a leader in the in-memory data grid market. We have been very positively placed against the competition. If you look at some of the quotes from leading analysts and researchers, they talk about how Software AG DBP makes Terracotta seamless business component for your application building. Also, we are at a point where there is a convergence happening in the technology, and I think that really enables some of these use cases, especially when you're converting a business to be digital. We all know that the data volumes are exponentially growing, but also on the other side, the cost of in-memory is very rapidly declining. So we are at a good point as far as technology convergence goes to move some of this high-speed data for real-time data access, low latency, predictable access to an in-memory data platform like Terracotta. if we look at some of the modern applications, and I'm talking about use cases from the last let's say 5 or 6 years, we have seen traditionally, these are the caching use cases where customers have moved to move their disk-based data to now fall into an in-memory tier. And this is to, for many reasons, and most of the reasons are around modernization of your IT applications, where there is a heavy desire to limit the response time, the response times from several seconds to milliseconds to now microseconds. So those are the kind of core business reason why people have moved data from a disk-based database like, your traditional relational databases, and also some NoSQL non-relational databases, which are more disk-based, into an in-memory tier. Now, as we look at some of these customer deployments in our ecosystem, we see some common usage pattern of Terracotta data platforms. One, the 2 boxes on the left show how Terracotta Big Memory product enables some of the caching use cases, and some of the key patterns in these deployments are around cache write through or cache aside, where the in-memory data platform is sitting in between the application and the system of record. And the system of record may be a traditional relational database like Oracle, or a NoSQL database like Cassandra or MongoDB. But we also see some very high-value use cases where customers have moved to using the Terracotta platform as an operational store. And I'll explain what that means. But essentially is removing the need of having your traditional database in the back. And some of the reasons why that has happened is because there is total resiliency in the platform, is highly available, and also there is a durability layer built in. So that enables you to actually start using Terracotta data platform as an operational store. Now, if we look at we saw the picture where, to modernize application, customer move from, move data which is more referential data or data which is accessed more frequently into an in-memory tier. But the use cases in the last 2 to 3 years are actually moving the entire data set into an in-memory platform. So basically getting rid of your reliance on a disk-based system or a system which is not very flexible and agile for building digital applications. And the other more important thing is that as this data set has moved to an in-memory tier, people do not want to again move this data to like a data warehouse or another tier to do analytics on it. They want to run analytics right where their operational and transactional data resides, right? So people are really looking for a unified data platform which provides both operational storage as well as analytical processing capabilities. So if you look at the various capabilities in the Software AG digital business platform around in-memory data management, there is Terracotta Big Memory, which is your in-memory data grid. There is streaming analytics engine. There is high-performance messaging, which leverages in-memory, and now we are introducing an in-memory DBMS, which is called Terracotta DB. And as a lot of you already know, Terracotta DB was launched last year. We had our first release, and some early customers already using the platform. So I wanted to quickly talk about, again, what Terracotta DB is. Again, it's a next generation built on next generation in-memory data platform, which is built on our Terracotta Big Memory foundation, being high performant. In addition to that, we have added translytical capabilities where you can do both analytical and operational storage at the same time. And again, we continue to support both scale up and scale out, thereby providing you in the flexibility in your scalable capacity. And also with this platform, a lot of our customers really are able to reduce the data management cost because, if you look at, use cases where people are offloading a lot of data from traditional databases or even mainframes, because that becomes very, very, very cost effective to move to a platform which is able to scale out and give you the agility to build new applications. Now, if you look at some of the architectures or deployments of Terracotta DB, you see that this is actually the Lambda architecture. A lot of architects call the Lambda architecture, where there's data coming in, and you have your traditional batch layer where you want to put your historical data and maybe do some batch analytics on it. And this is things like your data warehouse or maybe things like Hadoop and Spark. That's where that comes in. But there is this notion of a speed layer where you have high data ingest and you want to have access to this data in a very low latency, high throughput manner. And then you're able to also serve this data or be able to build dashboards on it or be able to visualize this data very quickly. So Terracotta DB basically fits into the speed layer for quick operational storage and quick access to data, but also fits into the serving layer, which enables you to build real-time insights and get you real-time insights from the very same data platform. Now, if we move to talking about the use cases where Terracotta is used, one is the as an operational data store, and I talked about how in the picture where you want to move your data from a disk-based data store to your entire data set, which your application may use, into an in-memory platform, and that gives you rapid access to data, and you can actually run mutations of the data, you can update the data, and also do search and analytics on top of that. So a complete operational data store use case. The other big use case we see for Terracotta DB is being able to deliver real-time analytics on the data. And Shailene is going to cover some of the compute capabilities in the next few minutes. But that basically shows how we are able to, on the same platform, push the compute closer to the data and therefore accelerate the analytics. So you will see how we can do things like predicate pushdown, where we can look at a query and actually push the compute in situ where the data resides. And the third and one of the very important use cases is around integration and this whole enablement of microservices. And we have done some key things, and Shailene is going to cover that in the demo, how we are enabling microservices, the building of microservices with Terracotta DB. And it is very natural for, if you're building in a microservices-based architecture, it's very natural for our customers to use platforms like Terracotta DB, because it gives you that encapsulation of persistence and gives you the agility, because as you're scaling out your microservices, you can also scale out your data store. So that's why it is very natural in a microservices architecture. So those are the three big use cases technical use cases for Terracotta DB. And with that, I wanted to hand over for a little bit of a technical deep dive and also a demo of the product to Shailene Prasad. Thank you.
Thank you, Manish. And I'm just going to share my screen here real quick. So a little bit of a technical deep dive I want to do here today to show what Terracotta DB is. My name is Shailene Prasad. I'm a Senior Manager for Product Development, Terracotta DB. So what is Terracotta DB, right? So that's one thing which probably a lot of you might be thinking that, what is it? So Terracotta DB, if you remember the use cases which Manish showed, the two common use cases which we talked about in caching world, the cache write through and the cache aside, and then the third one where we are trying to be used where in-memory plays a big role in an operational store or more of a system of record use case, right? So those were keeping those use cases in mind, we kind of came up with this concept that we're going to build a database which will have a complete two distinct set of APIs. So this slide which you see right now here is what I call a Falcon Wing slide, which means there's a central core system, and there's a left side and the right side. So left side is your core caching APIs, EHCache API, which is basically a next generation API of the caching APIs which is there in big memory. So it is based out of JSR 107. It supports JSR 107 APIs as well as it also has a modernized caching API, which we call it Java EHCache 3 APIs, right? So now I'm not highlighting all the features of EHCache APIs or TC Store APIs, but I'm just saying the highlights, right? So the key highlights of EHCache API is that it is definitely way more performant. So when I say better performance, you would imagine that better maybe 10% by its predecessor EHCache 2 APIs. Here what I'm talking about is not in the magnitude of 10% or 20%. I'm talking about in a magnitude of 200% or 300% better performance. Again, I'm going to put an asterisk there, like every car company does, 0 to 16, 4.5 seconds. That's under their testing conditions. So this is based on most of the test cases, benchmark test cases, which we have done. And we have seen that the performance improvement for EHCache 3 APIs are almost in the range of 200 to 300% better than EHCache 2 based APIs. Now that's so much about the caching. The highlight of this presentation and this whole demo is the new capability which we added, which is around the third use case, which is system of record use case, operational store use case, right? So what we did is with Terracotta DB, we built from scratch a new set of APIs, a TC Store API. And as you can see, a couple of highlights there is it provides you a distributed in-memory storage, not caching. It gives you a storage. So it was designed for your storage needs. It leverages Java streams and gives you an advanced search and computation capability. And I'm going to go into detail about that in the next few slides. And it's better performance. So a lot of time people ask me, Sheldon, what better performance as to what? So it is better performance as to using your caching with some, pinning and all that, and make it look like store. So it is definitely much better performant than that. And the beauty about this two APIs is both these APIs are backed by the same Terracotta server platform. So for both your, it gives you a unified data platform for all your caching, storage, and computational needs. So you can scale out your server as much as you want. It gives you all the consistency, durability, fault tolerant, HA, management monitoring, as well as now it also gives you an operational store capability. It gives you advanced search and analytics capabilities, right? In a nutshell, I want to cover the high-level features of Terracotta DB. So what Terracotta DB really, I'm talking about the right side of the API. What are the highlights of the new storage APIs and the capabilities which we introduced? So I'll say there are four major things. And if you see here, 3 of them are blue color and 1 of them is in a gray color. So why? Because you see data model, storage, computer and analytics. These are the 3 components which is built from scratch for your storage needs for the TC Store API. Distributed HA storage is, however, in gray. The reason why it is in gray is because from the beginning, Terracotta has been known and been very popular for its predictable latency at infinite scale. So it has been probably the best product when it comes to scaling out and get the throughput which you want. So we were best at that, and we don't want to change that, right? So we kept the distributed HA storage architecture which we had, and we built a completely new set of functionality around data models, new storage layer, and advanced computation and analytics capabilities. And it's all in memory, and that's what is going to serve you as a TC Store capability of Terracotta DB. Let's go into the details of each one of them really quick. So when I say data model, so traditionally, if you remember in an IMDG world, when I say key value like big memory, I'm talking about value being an opaque, a key and a value, and you don't have a visibility inside a value. So it's an opaque object, and if you want to do anything on that, you will have to probably marshal and then extract the content. With Terracotta DB, your value is not a cell. It's a set of cells. So what you see here in the gray is your keys, and what you see here in different other colors is your value. And the value comprise of cells which are strongly typed but loosely schemaed. What do I mean by that? So when I say strongly typed and loosely schemaed, I'm not saying a tight schema or no schema. When I say loosely schema means you cannot just put anything. So you need to have a type associated with a name, type, and a value. So you need to have a type which is supported type by Terracotta DB for every cell. And you can have a completely heterogeneous data set. So what we see here is a key and value, which is a set of cells, and this whole thing comprised into one record. These records can be totally heterogeneous from each other, and they form together a group, which is like a table in RDBMS world. We call it a data set. The only constraint there is the keys have to be a similar type, of the same type, and this can be completely different. So what does it give you? Why did we do that? In today's fast-changing business requirements, business world, you may have something which you're getting from what you need for your business right now, and you might want to adapt and enrich your data model for your business to adapt to the new requirements which are going to come in future. You want to have that capability and that flexibility that I'm not going to go ahead and redo things. I need that flexibility that today, if I'm getting an information about my customer, which is name and address and this and that, tomorrow I might want to know what kind of car he owns, right? Is he an electric car owner, or is he still using the combustion engine car? So I'm just giving an example. Maybe if you're in IoT space, you might have a sensor which gives you a temperature today. You might want to have a humidity which is coming in from the same sensor, and you want to start storing that. So you want to adapt and enrich your data as your business grows. And Terracotta DB is capable to fit your business needs when it comes to an aggregated oriented key value scale out store, because it is strongly typed and it's loosely schemaed. And I'll tell you why it is strongly typed later. Another big thing which we did is we built a completely new storage layer for Terracotta DB, built from scratch, designed for this high performance search and computation, backed by, because it's all in memory, we need to have a persistence. So we have a disk-based fast restartable store, which gives your Terracotta DB a persistent layer, right? And the key feature for the storage is now, by default, all your keys are hash-based indexed in memory, and you can add any cell, any cell within your value, additional indexes as you need, which is another memory index, tree-based index. And even without that, every cell within a particular data set is accessible to you. So if you want to make sure that you have a particular cell or a particular business artifact field you want to search on and be performant, you can actually add that later. You don't have to decide it right at the beginning like we used to do before when you have to pre-index stuff. So what I'm talking about here is it gives you a capability to add and drop indexes on the fly because it's all in memory. And that's a huge capability when it comes to a database, in-memory database, right? This is the highlight, and I want to spend some time here. So this is what Manish was talking about, that we want the data to be the data computation to be as fast as possible in today's day and age. So what we have done is we have extensively leveraged the capabilities of Java streams. Java 8 introduced the concept of streams, where we provide you functions which are out of the box, And those functions are basically our domain-specific language where you can actually write on those functions, and those are pre-implemented Lambda functions. So you can actually ship those functions directly to the server and do your computation on the server in situ and just get the result back. And that's powerful. You're not doing anything on the client. You're actually pushing it down. You do a predicate push down to the server for all your queries and run it on the server and get the results back. Now this is dependent upon what kind of functions you're using. We are adding more and more predefined functions, and with the current set, it's already very extensive. And if it doesn't, it comes to the client and executes that. So for example, in this case, you see a record stream called persons.record, and I'm saying go to the Terracotta server, look for anybody who has an age greater than 55, map those people, get their first name, collect into a list, and give it to me. This is my requirement, right? And look at the clarity of the code. So because Java functions are very good way of programming, right? So I do persons.record, open a stream, and then I say dot filter age value is greater than 55, right? Then I say dot map first name dot value, map that, get the value of the first name, and then dot collect to list. As you can see here, that particular stream query goes and scatter over each one of the stripe. All the sharded data gets that query sent out to them, and it gets executed on the server, and all you get is not the whole data here. All you get is Gary and Kim from here, Mary from the second shard, and Anne for the third shard. And on the client, obviously, the collection has to happen on the client. All you get is Mary, Kim, Gary, and Anne as your results. And that is extremely, extremely powerful functionality of Terracotta DB. The capability to do advanced search and analytics on the fly, on the server. Another thing which I want to highlight here is Terracotta DB, although it's something which was just released as a GA in October, it is really a very mature .O release. So we have what we have done is with Terracotta DB, we have out-of-the-box integrations right from the very first release with a visualization data with a visualization product, Mason. We have out-of-the-box integration with integration server, out-of-the-box integration with Apama streaming analytics capabilities. So if I have a data setting in Terracotta DB, I have a native access to Terracotta DB data with our visualization layer. So you can actually create dashboards, have an insight into your business without really spending time with just some point-and-click user-friendly data transformation visualization tool, right? And that's again something which we see that is extremely well received in the market. That this .O release of Terracotta DB, 10.0 release, has been so mature in that front. So I guess it's time for me to really show you what Terracotta DB in action. So give me a few minutes here. What I've done, let me just give you what I've done is I've started a two-stripe. So you can see here stripe 1, server 1.1 working as an active coordinator. And then I have server stripe 1, server 1.2, which is our mirror. So I have two shards. Then I have server 2, 2.1, which is active, and then the other one, which is standby. And I'm going to quickly show you. These are the two stripes, and they're all up and running. This is active, this is mirror, this is active, this is mirror, right? And you must, most of you must be familiar with this. It's an integration server up and running. What you get is, what we have done is out of the box, we have built an adapter called webMethod adapter for Terracotta DB. Nothing complicated here. It is built using the same ERT framework, which has been proven from last more than 10, 15 years. and has been very stable and very powerful to build all the adapters which we have, 40 or 45 plus adapters which we have. So we use the same framework and built a connector to Terracotta DB out of the box. So as you can see here, I'm going to go ahead and show you how easy it is to create a connection. So all I did is I'm not going to recreate one. So I just specify the connection name the package is going to sit in, the URI of Terracotta DB, one of the nodes. You can specify all of them if you want. And these are standard ERT parameters for your connection management. And guess what? I'm connected to Terracotta DB. So that's almost like 30 seconds start. The next thing, I want to go ahead and create a data set. I go ahead and I click on my connection where I'm going to, which cluster I'm going to go after. And I'm going to say test data set, key type string, and then it will ask you for one mandatory thing, which is off-heap resource name. This is almost like a table space in a database world, right? So since it's in-memory database, we need to tell where are you creating. A data set is equivalent to a table. So if I'm creating a table, I need to tell where is my table going to sit. In Oracle, you say this table space. So in Terracotta DB, you have to tell where is the memory space I'm going to create this data set. And if you look at the TC config file, this is the Terracotta config file. You define those memory space here. So in my server, which I've started up, I have defined two memory spaces, which we call it as off-heap resources. One called off-heap 1, 2 gigabytes, one called off-heap 2, 1 gigabyte, right? So I'm going to use one of them and go ahead and create a data set right here. So I'm going to say off-heap 1. This is optional. So another thing is if I want persistence so that my server goes down, my Terracotta DB has to restart, I don't lose my data, right? So I want something which can be backed by a file system. I said the storage layer actually supports a persistence through a fast restart store. So if you want that capability for your data sets, and the good thing is you can actually now have persistence per data set. So I can say for this data set, I want to have persistent data set. And I can pick one of the persistence folder. In this case, I have data root 1 and data root 2, which are my data persistence folder. I can have as many as I want, right? So we have decoupled the whole persistence with one single kind of point of storage. So if I go back here, I submit, and guess what? It says dataset test is successfully created. I can go ahead and I can see what data sets I have in my server, and it will give you the list, right? Same thing, I can go ahead and delete a data set if I want. All I have to do is select a connection, and there you go. It lists you all the data sets which you created. I'm going to just delete the one which is created. So that's so much about the administration of how to connect, how to create your tables and the data sets and all that. Now, what do we do with that? So let's go to your designer and see what we can do with that. Here, you see that I can actually go ahead. This is the connection which we created. All right. So I can create a service with just a click. So all I do is I go here, I select the data set, I select the key which is there, and I want to tell you guys the one good thing about this is it's schema-less, right? It's loosely schema. How do I know what kind of cells are sitting there, right? So what we have done is we have provided a capability to introspect within the data set through the UI, through this wizard. So I can say, I'm going to go ahead and sample the first 100 data stored in this person DS. And I want to go and populate all the fields, what you find there. So I'm going to just save that. And guess what? What I've told so far is connect to dataset DS, key type string, sample 100 records on the top, 100 records in general, and then get me the metadata information by introspecting those data. And guess what? It starts popping up, right? So it came back, which means it's done. You can actually do this much better. If I just do this, it will get you all that. So, and if I don't find something, I have a capability to actually go ahead and say, I want NIS document reference to go ahead and pass that. Well, I'm not going to go into all the detailed feature of how the adapter works, but I really want to show you the capability of adapting and enriching of data for your business needs and the power of computation on the server side. So what I have done here is I have pre-populated for the purpose of this demo 10,000 records of people with these fields. So name, surname, gender, eye color, birthday, height, weight, and wealth. All right. So when I've done that, I have written a small flow service. And you can see, if you're familiar with IS programming, creating this adapter services is really, really quick and easy. So what I've done is I have created a flow service, and I'm saying, go ahead and find me every one of the person record where it matches. I'm going to go with this one. Where it matches an eye color of a particular type, or a particular eye color, and where the wealth is more than certain number. So what I'm trying to do is, with this data of person data, I'm trying to filter out a target segment of people who can be marketed for Bosch & Lomb, right? So I'm saying, if you have an eye color green and you make more than 7, the wealth range is very much between 1,000 and 9,000 here. So I'm going to say, if you are a target audience, if you are a person who has, find me everyone who has green eyes and makes more than 5,000, go ahead and update each one of them with an additional field on those records. So this is where I'm talking about making your business adapt to your needs. So now what I'm trying to do is, I'm saying, can you go ahead and find all these people on the server and put a new field called target and make it true? So I'm going to do that. And you can see it's running. And it says I completed that, and I added a target field, and I updated 625 records. It took 12 seconds to do that. And this is, even if you do a very big number, it's going to be very similar. But this is all done on the client side because I'm looping through it and I'm getting it to the adapter. But it is very, very, very easy to build and do it using adapter services and flow services. It's not using the capability of streams, it's using CRUD, using the adapter. Let's say I want to do the same thing and I want a very high performance, my business required something similar. So what I've done is I actually altered the data set and added a new field called target, right? And I said, update that field and make certain fields as true. I want to show you the same thing, which I'm going to do using a Java service within IS. So here's my simple Java service, and all I'm doing here is I'm initializing an iData cursor, defining variables, and then I'm starting them some timer stuff and creating data set. These are the basically data set connection URI and which data set I'm going to go after. And look here, I'm going to talk about this a little bit. I'm going to show you. This is very cool. And all I'm doing is dot filter eye color, blah, blah, blah. Dot filter wealth is greater than whatever wealth is being passed. And then we say mutate and put a new cell, right? Target cell, new cell, target set. And I'm going to pass as true and return me the count of how many updates and upserts we have done here. So let's go ahead and run this. I'm going to probably have to pick another eye color. So I did green, I did blue. I'm going to do brown. Brown is there. So I'm saying find everybody with brown eyes, 5,000, and mark them as add a new field called target and make it true. Guess what? You saw a difference in the speed, right? Again, very similar because my data is very homogeneous. But look at execution time. It's 1.13. Like I said, it doesn't matter. Even if you do 10,000 or 20,000, 100,000, it's going to be very much, it's not going to rise exponentially because this is all, I'm going to show you this really cool stuff here. So the explain is basically giving you an execution plan, how the query was executed. And it shows that everything I said to be done was actually sent out to the server. Every single filter and function which I said was actually pushed down to the server and executed on the server. Nothing was non-portable. So it actually did almost close to 10 times faster than doing in an IS. Now I can do this and pass all the parameters and use this within my flow service if I want to have that. So the choice is ours. You have an out-of-the-box integration with integration server. You can use adapters. It's pretty neat. It's very easy to develop. It's pretty powerful, and the maintenance-wise, it's familiar technology. If you have a set of folks who are skilled in web method flow service development, and that's pretty good. And if you want a really, really high performance, and this is extraordinarily fast, I can tell you that. When you're doing, I'd take just 10,000 records, but I'm saying if you do that, the in situ updates and computation is really, really powerful, right? So that's about how you can use webMethods integration server with Terracotta DB and how you can leverage the adapter out-of-the-box functionality to really make good integrations and build your microservices. And the beauty about that is if you're using Terracotta DB along with in your microservice architecture, you can add your integration servers and they will all have an access to Terracotta DB, which is now natively deployable on cloud using Kubernetes. So you can have your caches, your distributed cache, your data sets, all able to access that and scale your integration server. So that, yeah, it's a pretty cool feature if you're looking at that. Now, another thing I wanted to show before I go into the Q&A more and talk about is it's out-of-the-box capability with mass zone visualization tool. So we did some stuff, and like I said, my data is very homogeneous, but I would like to show you a pre-built, I built this, I don't want to, person DS dashboard. This is directly, so all I can show you this. So if you go to mass zone, it's a visualization tool, right? I can actually go ahead and create a connection to Terracotta DB just like I do in IS, just from the UI. It offers you a capability to connect with Terracotta DB and it says, hey, I'm good, I can connect to it, right? And then once I am connected to Terracotta DB, I can go ahead and use Master Nexen to create dashboards using directly the feed coming from that connection and all the data sets available for creating a visualization layer. So here what I've done is I've just used some of the things, and I'm trying to show you how easy it is to actually directly go ahead. Like you see, my data is, although the colors, the black is in blue color, but that's not something which I'm interested in. I'm just showing you that almost all my records are very evenly distributed, and this is a visualization chart which is prepared directly from the same person DS data set which we were working on and enriching and adapting. So now if I go back here and I say go ahead and query 9,000 I want to do, and I want to say go ahead and query that. Do you see target? It was not there before. But now, since we did some runs, the target field is now been detected as another additional field which was added to the data set. The data got adapted, enriched, and it is ready to serve your business needs. That's your operational store which you want to use with your integration server, with your other Java applications and everything. That's very powerful. So with that, I wanted to go back to my presentation and excuse me. So these are some of the resources. If you are resources which I would like to highlight here, we have a trial download for Terracotta DB. You can go ahead to Terracotta. We have a community website, www.terracotta.org. Offers you trial downloads, product documentation, tech videos on the product, and it also has the open source project links. And with that, I would like to transfer the presentation back to Charlie. Thank you, everyone.
Thank you, Shaleen, and thank you, Manish. Before we go to Q&A, we do have a number of questions. I'd like to point out that Software AG is sponsoring 2 user group sessions. These events are about sharing best practices with fellow Software AG customers, meeting and discussing user experiences, seeing what's trending and what's coming up on the product roadmap. So please go to the Software AG site where you can register for either the San Francisco location on May 8th, or we'd love to see you May 10th in Austin, Texas for another deep dive discussion around web methods and Adabase and Natural. And in San Francisco, we'll also be discussing web methods products as well as Eris and Alphabet. And with that, I'd like to go to our first question. How does Terracotta DB compare to other in-memory data platforms?
Yeah, Charlie, hi, I can take that. So Terracotta DB, as might have been evident from the presentation, is a little different than some of the other data platforms. One of the key things is the capability to store data in memory. Terracotta DB is in memory by design, whereas if you look at some of the other data platforms, it's more of a add-on or something which got added later on, right? If you look at the traditional relational databases, now some of these databases have an in-memory option, so it is an add-on. And similarly, the case of some of the non-relational data stores as well. The second aspect of being different is the scalability. As you know, Shaleen pointed out that you can actually do both scale up and scale out, so that gives you a flexibility. Whereas the other platforms, some give you just scale up or just scale out. So we give you that flexibility to build agile applications. And the compute is the other thing which is a differentiator, where the compute is very, very rich, and all these well-known functions and pre-built lambdas are available so that you can actually push the compute back where the data resides. So those are the few things where Terracotta DB is different and differentiating solution.
Is it flexible and possible to export data and import to other relational databases when needed?
Yes. There are, as was pointed out in the presentation, the API where we have the TC Store API. So this provides, a full capability of doing create, read, update, delete. So yes, you can use these Java APIs to do, ingest and also, export it out or write it out to a different data store if there is a need. So we currently support Java APIs, and in future we'll be supporting other languages as well.
Do we have a roadmap to replace relational databases with Terracotta DB for Software AG product installation?
For Software AG products, there are some products which actually require a relational data storage. For some of the products actually have needs for having schema in the data, and not like what Terracotta DB supports. So for those products, they'll continue to leverage the traditional relational data stores. But yes, you will see that a lot of the platforms and products in the digital business DBP, software AG DBP stack will actually move to start using Terracotta DB as their operational storage.
Okay, thank you. And since we're looking at this particular slide, I just want to point out as we move along with Q&A, and there still is some time for additional questions, if you want to put those into the Q&A web box, we'd appreciate that. As you can see, there's Manish's and Charlene's contact information, which means we encourage you to reach out, particularly if a question occurs to you after the fact or after we've come to the conclusion of this particular session today. So I think you may have answered this one, Manish, but is there an additional charge for that Terracotta DB adapter?
Yes, as I had mentioned in the chat, the adapter is part of the data platform offering, and I would encourage you to the person who's asking the question for any pricing related, please contact your account executive for, if there would be a price differential or a charge for Terracotta DB adapter.
Is there a webMethods Terracotta package which has all the services to interact with TC just as relational database? I assume TC stands for Terracotta.
Was that, say that again, I'm sorry, Charlie?
The question is there a webMethods Terracotta package which has all the services to interact with TC just as a relational database?
So I would start by saying that there is a fundamental impedance mismatch between a relational database and a NoSQL database. So they are meant for different use cases. Now, is there a webMethod package? Yes, Terracotta DB adapter is a package on webMethod which gives you an access to Terracotta DB where you can create services. You can also perform some admin task as well. There are services, and we are going to keep enhancing that so that you get more capabilities added as convenience services to do operations on Terracotta DB. But will it ever be a relational database? It is not intended to be a relational database.
Thanks for that clarification. And I know you touched on this, but can you talk a little more about the relevance of Terracotta DB in building microservices?
Yes. So traditionally, if you look at a microservice architecture, right? So what made people think microservice? And the main thing was I want my business to be exposed as microservices so that I scale what I need to scale, and I don't have a monolithic approach that everything has to grow together or shrink together, right? I break it down into microservices, and there needs to be in-memory database. A scalable in-memory database is a very big pillar for your successful microservice architecture. And one of the things I would like to highlight is that if I have a clustered cache and my Terracotta DB is sitting on your cloud, and I have an integration server microservice container which is running for various different needs, and I'm using that, I'm just taking cache as an example for now. I know that when I need to scale my inventory management microservice, and I'm keeping those inventories in a distributed cache on my cloud infrastructure, as my client becomes scale, it doesn't matter. They don't have a ramp up time because that distributed cache is accessible to all this client right away. And that's where it plays a very important role to have a scalable, fault tolerant, highly performant in-memory database, or not just in-memory database on the cloud to augment your microservice architecture. Does that, yeah, if you have any further questions, reach out to me.
For a heavy transactional online transaction processing application database. How is integrity maintained in Terracotta DB since we say the data is in memory?
For a heavy transactional requirement, how is the integrity maintained? That's our secret recipe. So we do guarantee. So Terracotta DB is by default not an eventual write. It is what do you call, strongly consistent. It's not eventually consistent. It is strongly consistent. So the writes which you do are making sure that it is written down before anybody else can write it. And it's the way we build the system to guarantee you that, you know, that consistency is maintained. So that's again, I want to tell you something that, again, I don't want to go into that whole theory here, but when you go into a distributed architecture and in a distributed storage engine, the trade-offs which you have to keep in mind is always that your consistency is a trade-off for your availability. The CAP theorem, the classic CAP theorem. If I really want to have my availability to the max, then I will have to trade off on my consistency. But you can always do the other way as well. But the very fact that distributed systems came into the picture was because there were applications which needed really fast availability of the data, really quick access, and make sure the data is always available to them. And consistency was something which the application was ready to cope up with.
Great, thank you. We're coming toward the top of the hour. Let's see if we can put in 2 more questions. Can you elaborate on the SQ access on the top of Terracotta DB?
SQL access. So
yes,
what
please.
we have done is we have added with 10.2 release, 10.2 release in April, we have added a new API extension on top of our core Java APIs for storage needs. We call it as TCTQL, Terracotta Textual Query Language API. That API is basically a SQL-like language which you can pass within a Java framework. So it's an extension API where you don't have to write Java functions, streams. You can write your queries in SQL-like syntax. Why I'm saying SQL-like is because it's SQL plus some additional functions which is needed for us. So it's SQL-like grammar, which you can pass to your Terracotta DB, and it will translate down. It will be translated down into functions, streams, and then whatever component is portable, it will be pushed onto the server, as I explained earlier, and then you get it. So it's right now going to be available with April release. Like I said, it's a very good way of doing your search and queries using a familiar language practice.
Thank you. We have time for 1 more question, and of course we invite any additional questions, or we will respond to any additional questions that we weren't able to get to. We promise you that. And of course we want you to be aware of the upcoming digital business demos on the program. We're quite busy with them from week to week, so we hope we'll see you there. And finally, are there any JDBC drivers available for Terracotta DB?
Nothing right now. JDBC drivers are very native to a relational database, and the whole notion of providing a SQL-like interface on top of Terracotta DB as an API extension was our step towards giving a capability where developers and application owners can actually use a familiar language practice to access data and do queries on Terracotta DB. So we don't have any JDBC driver for Terracotta DB yet.
Our thanks once again to Manish Devgan, Charlene Prasad, and we hope we'll see you again next week at Digital Business Demos, where we provide live demos every time. Until then, have a great rest of the day.